Hello everyone. Today I, Debankit and my friend Saswat Kumar Pati are going to give a lecture on hypothesis testing and statistical significance towards the fulfillment of grading in CS460 of NISER. So, what is machine learning? In today's world, machine learning is very important aspect of research and many modernization. So what is it? A subset of artificial intelligence, machine learning is the area of computational science that focuses on analyzing and interpreting pattern and structures in data to enable learning, reasoning, and decision making outside of human interaction. This is the definition, textbook based definition of machine learning. So we have a data set, a huge number of data set, means containing number of rows of data for a particular, let's say, drug. Okay, so we want to build a model using machine learning to basically predict new type of drug which will have similar effect on a disease using the previous data that I told you. So this is called machine learning. And different areas of today's life, machine learning is widely used. Healthcare and life sciences are the best example for disease identification and risk satisfaction, and also to predict new drugs and various other uses. Travel and hospitality, dynamic pricing. So if the pricing of hotels, houses, and real estate and other things can also be predicted using machine learning using the past various pricings of the same. And financial services, risk analytics and regulation. This will, let's say you want a loan from a bank. So the bank can predict what kind of people are very highly likely to have a huge risk in repaying the loan, and which type of people are highly likely to pay back the loan in the given time. This can also be predicted using the machine learning. So these are the uses of machine learning. So the good data. So as I told you, machine learning requires a huge amount of data for its prediction. So what is data? Means what is also good data? So in machine learning, what we do is we train a model. Let's say it can be a linear regression or classification. If you want to classify two things, means to classify the observations into two things or more. So that is called classification. So all this model training requires a training data. So basically the data I told you, it's called training data because it is used to train the model. Training data requires some human involvement to analyze or process the data for machine learning use, because the kind of data we want is not readily available in nature. So we humans have to convert the nature data that we observe and see and other things to a formatted data which can be used by the machine, which the machine understands and can be used to predict. So this point is important because this involves the human involvement. So how people are involved depends on the type of machine learning algorithms you are using and the type of problem that they are intended to solve. Like I said, if you want a classification algorithm, then you want a label on each data determining which class it belongs to, so that it will predict for the new data. Otherwise, if it's regression and other things, then that will correspondingly include other type of involvement. So the quality and quantity of data that you gather will determine how good your predictive model could be. Both are important, quality and quantity. If there is a bad data, the bad, I mean, if many of the data cells are missing or other things, then that is bad quality data. And also if very less number of data is there, then the model prediction is not so good. So both quality and quantity are important. Tidy data, it's similar to what it's almost the same as good data. So basically the kind of data we want for a machine learning algorithm. So in tidy data, three important things are there. So first thing is each variable must have its own column. Let's say the Excel sheet is here. And these are the observations, 1, 2, 3, and these are the columns, column 1, column 2, column 3. So this is called feature vector, because this is kind of a vector which has different features, and these are the different features, this one, this one, this one. So each variable must have its own column. That is the first point in tidy data. Then each observation must have its own row. So basically these are the feature vectors that I mentioned. So each observation, let's say there are 10 people with different heights. So the 10 people are the observations, and the heights, basically the height is a feature of those observations. If we include skin color, eye color, iris color, these are all other features of these observations. So this is a second number, second quality in the tidy data, and every cell should have a single value. Means let's say for person number 1, his height should be 169 centimeter. That is a single value. It can't be, and it shouldn't be more than one value, obviously. So if a data set contains more than one value in a single cell, then that is not tidy data, and there is something very wrong here. So we have to convert it, and we have to check it. So this involves the human involvement, as we discussed in the previous slide. So this is tidy data. So, but what is the importance of data? Like I said, it is used in machine learning, but why is it so important to have a good data? So why is data required? Without the data, we can't train any model, and all modern research and automation will go in vain. The Google Maps is also a machine learning mediated model. The search algorithms, everything requires data. So big enterprises are spending lots of money just to gather as much as data as possible. So it includes Microsoft, Google, and any kind of enterprise which have involvement in machine learning are spending lots of money to gather the data. So the data is very important, and good quality data is more important. What is statistical significance? Let's come to our main topic. So if our machine learning model predicts that the average height of a state, let's say state of Odisha, is around 5.6 meter of each person. So this is a prediction by machine learning model. But we have the data, it's raw data of the Odisha state of all the heights. So in that we see that if we take a small amount in a region, let's say of 10 people, and we take the average of them, we are getting around, let's say 6.2 meter. So how significant is this observation? That is statistical significance. Means if we take the overall average of the Odisha as 5.6 meter that is given by the machine learning model, how much is the probability that we get the average of these 10 papers as 6.2? This is the overview of statistical significance. So let's read out once. Statistical significance is determination made by an analyst that the results in the data are not explainable by chance alone. In our case, the results of the average height of these 10 people, that is 6.2, is not by chance. Or is it by chance? That is what statistical significance says. If it is not by any chance, then this observation is significant in our statistics. Statistical significance is a determination about null hypothesis. We will learn about null hypothesis more in the next slides, which suggests that the results are due to chance alone. A dataset provides statistical significance when the p-value is sufficiently small. These definitions we will go over in the next slides. If the p-value is sufficiently small or large, determines the significance of the observation. Statistical hypothesis testing is used to determine whether the data is statistically significant. Means the observed data of the, let's say, of the 10 people that we observe, the average height is statistically significant or not. The method we use is hypothesis testing. So statistical significance is often used to test the effectiveness of new medicinal products, including drugs, devices, and vaccines. They check the extreme outlying cases are significant or not using this method. Also, there are different publicly available reports of statistical significance. Also, inform investors on how successful the company is at releasing new products. So the investors also use this method to see what a good company or what a new company will release their new products. So how much is significant in those. Then the stock prices of pharmaceutical companies are often affected strongly by announcements in the statistical significance of the new products. Yes, if the of the new in the new products, sorry about that. So the new products statistical significance determines the pharmaceutical company stock prices. So this statistical significance is very important in a data analysis. Now I welcome Saswat Kumar Pati to go over this hypothesis testing thoroughly using different examples that he has prepared.
Hello everyone. Thank you, Debankit. So now as Debankit has already discussed why we need hypothesis testing in an statistical and environment or while solving an ML problem. But so let's get to know what exactly is hypothesis testing. So hypothesis testing, to just reiterate the definition as written here. So it's basically a statistical method given any hypothesis. If we need to know how true it is, or we need to know the confidence level of the given hypothesis, we employ certain statistical methods or testing techniques to garner some statistical decisions, or basically what you can say scientific inferences from the given experimental data. And now usually this experimental data is gathered from a very specific or small subset of the whole population. As we go on, I will give you certain examples where hypothesis testing is plays a pivotal role, then we'll be able to understand it more clearly. So I'm sorry. Yeah. Okay. So yeah, exactly. The process of hypothesis testing is to draw inferences or some conclusion about the overall population or data by conducting some statistical tests on a sample. Okay. Okay. So now let me give an example, and on the basis of that example, I'll be defining some terms and definitions, and these terms and definitions are important to understand how exactly hypothesis testing is done. So let's say you are a t-shirt manufacturer and you wish to know the heights of all of your target consumer base. Let's say you are a t-shirt manufacturer and your consumer base is in the town Bhubaneswar. Okay, and you wish to know the heights of each and every man and woman. Okay, so for the t-shirt sizes, so let's say you gather up let's say you gather up 100 people at unit 1 market square, and you physically measure their heights, and you get a specific distribution. Okay, let's say that's mean is 165 centimeters. Okay. You have got the data. Now you can go and start manufacturing of your t-shirts. Wait, hold on a second. Now there is this mad person named Null. He comes in and says that what you sorry. So he comes in and says that whatever data you have gathered, it's wrong. He says that the height, that he knows the height of each and every man and woman in Bhubaneswar, and it is, let's say, 150 centimeters. Okay, so he claims that he has some domain knowledge. He has been living in Bhubaneswar for, let's say, 20 years or whatever. So this statement, we'll call it the null hypothesis or H naught. Okay, for the sake of the example, let us assume that this mad person named Null is correct. Let's be conservative and let's reject our experimental data that we have gathered from a very small population that may or may not be a representation of the whole population of Mishra. So the statement that H naught says is the hypothesis or the null hypothesis is that the mean height of every man and woman of all men and women in Bhubaneswar is 150 centimeter. So this is the status quo, okay? Believing that there is no anomaly present in our distribution. Everything falls right in the slot. Let's say, let's name the experimental data that we have gathered from exactly 100 people as alternate hypothesis. And the alternate hypothesis says that the mean height of all people is 165 centimeter. Okay. Uh, it cannot be one of these two, right? Or in a way, we can write that HA states that alternate hypothesis states that the mean height of all men and women in Bhubaneswar is not equal to 150 centimeter. Now, as you can see that H naught and HA are mutually exclusive. Both of them cannot be true at the same time. Okay, so now we have to see if either our alternate hypothesis is correct or our null hypothesis is correct. But usually in most of the ML problems, we alternate hypothesis is the inference that we are getting from a specific portion of the data set that we are trying to claim, but often it is very difficult to prove a new theory, a new hypothesis. So what people do, what scientists do is they try to disprove the existing hypothesis. Thereby, the second hypothesis or the alternate hypothesis that is just edging on is becomes the correct one. Okay. So when it is difficult to prove alternate hypothesis, but it is relatively easier to disprove the null hypothesis. So that's what we will try doing here. We will try to disprove the mad person's hypothesis that the height of all people in Bhubaneswar is 150 centimeter. How to do that? There is another term that is known as p-value, as you can see in your screen. So what p-value represents is p-value by definition is that p-value is the probability that given that our null hypothesis is true, given that the average height of each and every person in Bhubaneswar is 150 centimeter, the specific population of that 100 people from unit and market is 165 centimeter. What is the probability that that specific set of people will have the average height of 165 centimeter, but still the average height of all the population of Bhubaneswar stays 150 centimeter? So that is denoted by p-value. Now let's say for convenience sake, this probability for this particular case comes out to be, let's say, 0.04 or 4%. This will come in handy to compare something that will come in the next slide. So before comparing, let's define one new term that is known as significance level. So this is basically a pre-chosen threshold value sort of that represents that basically represents our confidence level in the dataset. For different datasets, this is different. So on the basis of comparison of p-value and that is denoted by p and significance level, that is represented by, let's say, alpha. By comparing these two values, we can either reject or fail to reject null hypothesis. Now remember, again, I'm saying that we are not proving that the alternate hypothesis is correct. We are simply rejecting the null hypothesis or failing to reject the null hypothesis. Based on that, we are inferring that alternate hypothesis may be correct. So p-value is usually as a standard, as a basic threshold, taken to be 0.05 or 5%. So as we learned in the previous slide, for this particular data set, we got a p-value to be 0.04. 0.04 is less than 0.05. Sorry. So what we got here is that p-value is less than alpha. So the probability that this particular 165 centimeter or more heighted, like taller people existing at that particular place, is the probability is less. So we can infer from this that our null hypothesis is not holding anymore. So that means our alternate hypothesis may be correct. Okay, let's take another case. What if p-value was 0.06? Okay, or the probability was 6%? Then p-value is this is, let's say, case 1, this is case 2. P-value is greater than alpha. That means the probability that there are certain 100 people at unit 1 market whose height is 165 centimeter, that is greater than the city's average, is greater than 0.05%, the probability of having that particular population. Then we can say that our null hypothesis is still holding. So our alternate, we cannot say anything about the alternate hypothesis, but we are failing to reject the null hypothesis. So basically there is another term, confidence level. It is basically 1 minus alpha. So for the first, for convenience sake, when we took significance level to be 0.05, so then confidence level shall be 0.95. Okay, now let's delve into how exactly what exactly is the methodology of hypothesis testing. We'll go step by step. So on the starting of hypothesis testing, we have to formulate certain null hypothesis and alternate hypotheses. So null hypothesis is the thing, is a conservative or ab initio idea that we may have to dispute, may have to disprove. Okay, and so null hypothesis is obtained from most of the time domain knowledge, and alternate hypothesis is interpreted from the specific sample data that we have got just now. So this is mostly an extreme interference that we are checking if this is just out of randomness. Is this just a fluke, or is there a particular pattern to this certain new data, certain new pattern in the alternate hypothesis? That is, so this will be the step 1. The step 2 is to set a particular significance level for the test data. This differs from data to data, and in most cases it is taken to be 0.05. The third step is to compile the sample data and compute the test statistics. Now, this is a very important term, test statistics. In the coming slides, we will exactly describe what are the test statistics and what exact tests are employed to perform hypothesis testing, given any different data set are present. Then the next step is to compute the p-value. Okay, so p-value is, as I have defined earlier, p-value is basically the probability that sample data is observed given that h naught, or the null hypothesis, is correct. So the next step is to interpret the given p data. Okay, if p-value is greater than significance level, that is the probability that in that example that I have already talked about, that certain taller people can be found, or let's say at some other place certain shorter headed people were found, so that extremities are touched, given that the null hypothesis is correct, then we fail to reject the null hypothesis, that says that the average height of the entire city is 150 centimeter. We fail to reject it. That means the null hypothesis holds, and we cannot say anything about the alternate hypothesis. But if the null hypothesis is rejected, the next best hypothesis, that is the alternate hypothesis, flames up, and that is the we can prove that, yeah, we can logically say that yes, alternate hypothesis is holding now, null hypothesis is not holding. Okay, so that is how hypothesis testing is done. What kind of results we should expect and how to interpret? I have already discussed this. If p is less than alpha, we reject the null hypothesis, and if p is greater than alpha, we fail to reject the null hypothesis. Okay, so let's discuss how many types of hypothesis testing are there. Okay, so statisticians have given devised several types of hypothesis testing. Basically all of them have a basic framework that we have discussed before, but on the basis of how they are implemented, they are divided into several categories. Now discussing all this is not in the scope of this class or this video, so we will be discussing the most commonly used ones that are very easy to implement, that are the t-test. I think, yeah, just a second. Mhm. that are the t-test and, sorry, that is the t-test and the z-test. Also ANOVA is also a famous one, will not be discussing that. So let's start with t-test. Okay, um, sorry, yeah. So basically what t-test does is, so this is the mathematical formula of t-test, where x bar is the sample mean. Sample means the small data set that we have, that we are focusing on, and mu is the proposed constant for the for the population mean. So mu represents the mean of the entire population or the bigger data set. Okay, so basically we can say mu represents the null hypothesis, and x bar represents the alternative hypothesis, where the denominator is the standard deviation that we know how to find out. Sample standard deviation divided by the sample size, root over of the sample size. Now let's run it on Google Colab and see how this exactly works. So yeah, as I already discussed, a t-test is a type of inferential statistics which is used to determine if there is a significant difference between the means of two groups, which may be related in certain features. So here the two groups, one is the bigger parent group, and the other is the sample data that is the more concentrated on. Okay, the same thing that we discussed. First, I imported this stats as stats, and this is the basic standard stuff. We can okay, basically these are pretty standard stuff. Okay, so here an example that I have taken is, I have considered a bigger group of 30 people, let's say, that has different ages. I have randomly picked up some ages, and we see that the number of, yeah, exactly. So I have 30, I have a population of 30 with different ages. So now I import numpy, and here np dot mean means we want to find out the mean of this data set, whole data set. We find out the mean to be 31.633. Okay, now let's focus on a small sample size. Okay, that let's our small sample size be of 10 people. So out of this 30, we were focusing on 10 people, and we are seeing if they actually represent, their mean is comparable to the mean of whole data set. So basically the mean of the whole data set will be our will be represented by the null hypothesis, and the mean of the sample, this small sample data set, will be represented by the alternative hypothesis. So I have randomly chosen the age, the samples by I have randomly chosen 10 people and taken their ages, and yeah, so choose this 28, 44, 11, 32, and so on. Okay, so now we are going to actually perform the t-test. So what this particular I have just imported it from the SciPy library. So what one SAMP means that there are also variations within Ttest, one sample, two sample. So we will not go so as much deep into that. But yeah, so this is where we are calling the Ttest function. Basically, we are instructing the machine to calculate this thing. Okay. Let's see if that runs. Yeah. So what we need is the p-value, and what this 32 number means that I'm instructing the machine that the value that we should get should be that the mean value is close to 32, so it can proceed. So let's say I run this too, and we basically need the p-value as the most important indicator for drawing our conclusions and inferences. Yeah, so we get the p-value to be 0.09989. Again, as we discussed earlier, if p-value is less than 0.05, here 0.05 is the significance value taken randomly as a benchmark kind of thing. You can change it also. So if p-value is less than 0.05, we reject the null hypothesis. That is, the alternative hypothesis is correct. But if the p-value is greater than 0.05, we accept the null hypothesis. That means that given the null hypothesis stands, we can get a small sample size whose mean or whose mean distribution would be justified under the null hypothesis. So null hypothesis holds. Here the null hypothesis is accepted as p-value is greater than 0.05. Thank you.
So let's see what is the Z-test. So the Z-test is a statistical test to determine whether the population means are different when the variances are known and the sample size is large. These are the two conditions to implement Z-test. As we saw, if there is a sample size of around let's say less than 50, then we usually use T-test. More than 50, let's say around 200, 500, 1000, we use Z-test. So Z-test used when the sample size is large or the population variance is known. Population variance is a characteristic of the data set. So if we know that, then we can implement the Z-test. When usually the sample size is low or the variance is not known, T-test is used. So to implement Z-test, that is very easy. We just have to implement a ready-made library made for the Z-test, which is, you can see the start models.stat import weight stats as Ttest. So Ttest contain the Z-test function. Here the heights, if we can see the heights, the first parameter is the sample data, that is around 200 to 300, I'd say, data points, and x2. X2 is let's say if we want to there is another test called the dual Z-test, where we compare two sample data sets. So we do not require that in this present scenario. So we take x2 equal to none, and the value which is the null hypothesis that we have already is input given as 1.9 here. So by calling this, the p-value contains the required probability, that is the p-value for comparison with the significance level. So using implementing this in our code, we can calculate the p-value using Z-test. Okay, so let's talk about some important topics regarding the hypothesis testing. Let's talk about some common misinterpretation. So as we have learned, the p-value and the conditional probability is what shows the significance of the sample data. So always we confuse that p-value and the conditional probability that it stands for is when H0 is true, the probability that sample data. But this is not correct. We are finding the probability of getting the sample data even if the null hypothesis is true. That is the second part. So this conditional probability is the correct one, and we should not confuse between these two. And second, tuning of the significance level parameter alpha. Let's say you perform a data analysis and you have initially thought that the significance level should be 5%. And your result, the p-value, is coming around 3.5%. Okay. So according to this, the null hypothesis is false. But due to some external factors, let's say your financial support depends on this significance. So what you do, you decrease the significance level parameter alpha to 3%. Then the null hypothesis is true. But this is unethical, because in doing so, it may lead to many types of disastrous effects that you don't know yet. If the data analysis is done on a, let's say, toxic substance in the food, regarding that, then this arbitrary change in the significance level parameter may result in many lives. So this is very important. So before doing the data analysis, the significance level parameter should be fixed. Then making exact claims about null hypothesis. We can never say that the null hypothesis is true or false 100%, because this hypothesis testing is a probabilistic claim that we get from the test. So we can only say that if we are rejecting the null hypothesis due to the p-value being less than the sample significance level parameter alpha, then we are saying with, let's say, 95% confidence we are rejecting the null hypothesis. Or up to a certain probabilistic confidence we are rejecting the null hypothesis. We can never say that null hypothesis is totally incorrect. So that is the misinterpretation. These three are the misinterpretation, and these are very important. Let's talk about some errors in hypothesis testing. Hypothesis testing only makes probability claims about its outcomes. This we have talked about. So let's see type 1 error. So in this error occurs when you reject your null hypothesis, when in reality the null hypothesis is true. This is called type 1 error. The significance level alpha sets the probability of making a type 1 error, as we are going to reject the null hypothesis, provided the sample data returns a value whose probability of happening is less than alpha. So the maximum probability is alpha. Maximum probability of making a type 1 error is alpha. Now let's talk about the type 2 error. So this error occurs when you fail to reject the null hypothesis depending on the p-value and significance level, when in reality the null hypothesis is false. So you are failing to reject even if that is false. So the probability of this error not only depends on alpha, but also the area overlap between true distribution and the distribution as given by null hypothesis. Let's say some part of the data due to the null hypothesis is false, it's corresponding to false and corresponding to true. So because the overlap between these two distributions, the probability of this error depends on it. So higher the overlap, more is the possibility of type 2 error. So this type of error is quantified mathematically by defining a parameter called power as follows. That is, we are subtracting the probability of making a type 2 error from 1, because these are the two types of errors. So the only parameter in our hand that can be used to minimize these errors is alpha. But as mentioned earlier, alpha should be chosen before any sample analysis is performed. So these are the types of errors when we are considering the hypothesis testing. Thank you, everyone. These are some of the references we have used in our lecture video. Thank you.